Look at this rock. To the untrained eye, it is debris, a cosmic leftover from the violent birth of our solar system, drifting silently in the dark between Mars and Jupiter. It is ugly. It is desolate. It is dead. But to an astrophysicist, and increasingly to the world's boldest economists, this is not debris. It is a bank account. A single metallic asteroid, just 1 kilometer wide, can contain more platinum than has ever been mined in the history of human civilization. We fight wars over resources on Earth. We destroy rainforests for copper and lithium. Yet, drifting right above our heads, untouched, is the solution. This is the Main Asteroid Belt. NASA estimates the mineral wealth here could exceed $700 quintillion. That is a 7 followed by 20 zeros. If you divided that check evenly, it is enough to give every single person on Earth $100 billion. But let me be clear, the race to mine the belt isn't just about making trillionaires. It is about the survival of our species. We are currently a single-planet civilization living on finite resources. The asteroid belt is our gateway to becoming something much more. To understand the treasure, you must understand the history. 4.6 billion years ago, our solar system was a chaotic disk of dust and gas. Gravity pulled this dust together to form planets: Mercury, Venus, Earth, Mars. But between Mars and Jupiter, something went wrong. A planet tried to form, but the immense gravitational influence of Jupiter, the bully of the solar system, kept smashing these rocks apart, preventing them from coalescing into a single world. What remains is the solar system's scrapyard, a collection of pristine building blocks that never underwent the geological recycling that happens on Earth. On Earth, heavy metals sank to the core when the planet was molten. They are hard to reach. In the asteroid belt, those metals are right there on the surface, waiting to be picked up. Not all asteroids are created equal. In this celestial quarry, we are hunting for 3 specific types. Think of this as the cosmic menu. First, the C-type. Carbonaceous, dark as coal. These are the most common, making up 75% of the belt. To a gold miner, these look worthless. But to a rocket scientist, these are the most valuable objects in the galaxy. Why? Because they are rich in volatiles. Specifically, water. Water is heavy. Launching a single liter of water from Earth to orbit can cost thousands of dollars. But C-type asteroids are essentially dirty snowballs. If we mine them, we can split that water into hydrogen and oxygen. That isn't just air for astronauts to breathe, it is liquid hydrogen rocket fuel. These asteroids are not gold mines, they are gas stations. Next, the S-types. Stony asteroids. These contain iron, magnesium, and silicates. They are the building materials, the concrete and steel we will use to build stations. And then, there are the M-types, the metallic monsters. These are rare, likely the shattered cores of ancient protoplanets that were stripped of their crusts in violent collisions. The crown jewel of the M-types is 16 Psyche. 16 Psyche is 220 kilometers wide. Radar data suggests it is packed with iron, nickel, and significant amounts of platinum group metals. Its estimated value alone could theoretically implode the global economy. But value in space is a tricky equation. So how do we get it? You cannot just send a team of drillers like in the movies. On an asteroid, there is almost no gravity. If you swung a pickaxe, the force of the swing would launch you backwards into the void. Mining here requires elegance, not brute force. Engineers are developing optical mining. We use massive mirrors to concentrate sunlight onto the asteroid's surface. The concentrated heat sublimate the volatiles, turning ice directly into gas, which we capture in massive inflatable bags. For the metals, we might use magnetic rakes to pull loose grains of iron and nickel from the regolith. We don't dig, we harvest. But we have to address the elephant in the room, the economics. We have the targets. We have the maps. Why haven't we started? Because space mining is a physics problem disguised as an economic one. The main belt is far. The energy required, the delta V, to drag heavy metals from deep space back to Earth creates a paradox. The platinum you mine might be worth billions, but if it costs billions in fuel to bring it back, your profit is zero. This is why the smartest minds in astrophysics know the truth. We won't bring the asteroid belt to Earth. We will bring Earth's industry to the belt. This is called in situ resource utilization. We don't mine steel and space to build skyscrapers in New York. That makes no sense. We mine it to build rotating habitats, deep space cruisers, and solar arrays in orbit. The first trillionaire won't be an importer selling gold to jewelry stores. They will be a construction magnate selling steel to NASA and SpaceX in zero-G. But before the drills spin up, we must face a terrestrial hurdle. Who owns the sky? The 1967 Outer Space Treaty forbids any nation from claiming sovereignty over a celestial body. You cannot plant a flag on Psyche and call it America, or China, or Luxembourg. However, the treaty says nothing about resources. Recent legal frameworks, driven by the US and Luxembourg, operate on a maritime precedent. You can't own the ocean, but if you catch a fish, the fish is yours. This is a legal Wild West. And right now, the sheriffs are still on the launch pad. China is planning missions to near-Earth asteroids. The US has the Artemis Accords. The race is on to establish the rules of the road before the traffic starts. We are standing on the shore of a cosmic ocean, fighting over grains of sand, while entire continents of wealth drift just out of reach. We are rapidly depleting the resources of Earth. Rare earth elements are becoming rarer. The asteroid belt offers us a choice. We can continue to scramble for scraps on a finite planet, or we can look up and access a supply of energy and raw materials that is, for all intents and purposes, infinite. The technology exists. The math holds up. The rocks are waiting. The only question remaining is not if we will mine the stars, but who will get there first. Look up.